Hello, students, and welcome to the last section of Chapter 5. We did do 5.1, 5.2, then 5.4, 5.5, and now we're coming back to 5.3, because 5.3 was a little different than the rest of them. 5.3 has to do with solving trigonometric equations. I'm going to do this lesson in 2 different videos because it's kind of long, but it's going to be pretty much normal like the rest of the ones we've done. One thing you're going to need today for sure is you're going to need to have Desmos open as well. So please open up a page of Desmos because Desmos will really help. In fact, you can pretty much solve all of these equations graphically if you'd want to, and I'll show you how. Before we get started, I would just like to address this one question of what makes something an identity to be verified and other things an equation to be solved. If you look at this, for example, we've been doing identify this. And now I'm telling you, solve this. So here is the question. What makes an identity an identity, and what makes an equation an equation? Well, here's the answer. An identity is true for any value of x. It doesn't matter what you plug in for x, here, here, and here. The left side is going to be equal to the right side. An equation to be solved is not necessarily an identity, unless x equals all real numbers. When you're trying to solve an equation, you're trying to find a specific value of x that will make the equation true. And only a specific value or some specific values will make it true, but not any value of x. So that's what we're doing now. We have to find a value of x that will make this equation true. There are 4 learning targets. Here they are. We're going to do the first 2 in the first video and do the last 2 in the second video. So let's start. This first learning target is we're just going to use standard algebraic techniques to solve trigonometric equations. This one's fairly easy, and once again, I've put the homework numbers right there so you know what this video is for. So let's solve it. Well, one thing you might want to start with on this guy is adding the sign to both sides. So we can get the signs together. So adding a sign to the left and adding a sign of x to the right, we're going to end up getting 2 times the sign of x plus the square root of 2 equals 0. Now subtracting the square root of 2 from both sides, because remember, we're trying to solve for the sign of x. We're trying to get the sign of x by itself, and therefore I'm going to get that the sign of x equals negative root 2 over 2. Now that's good, but that's not the answer. I'm actually trying to figure out what does x equal. So for this one in particular, you can just go to your unit circle. Go to your unit circle and find the spots where the sign of x equals negative root 2 over 2. X, of course, is the y value, and there are 2 spots on the unit circle where the y value is negative root 2 over 2. You can find them yourself. Here they are. The 2 spots are going to be 225 degrees as well as 315 degrees. And I'm using degrees for this example. So you might be thinking, good, I'm done. Close. Let's go ahead and take a look at the graph of this. So I'm going to go to switch off to Desmos here. Where is Desmos? Right there. Okay. And what I've done is I've graphed y equals the sign of x. So if I want to know where is the sign of x equal to root 2 over negative 2, I can graph them together. And the one thing I notice is that these are some of my solutions, 225 degrees and 315 degrees. But there's a problem. A sine function is periodic. That means it repeats over and over and over again. So we don't have just these 2 solutions. We're going to have an infinite number of solutions, including 585, 675. And as you might notice, what's happening is every 360 degrees, I have another solution. 360 plus 315, that's 675. So every 360 degrees, these 2 solutions are going to repeat. So I need to note that in my solution. So my answer is going to be, sure, x can equal 315, but x could equal 315 plus 360 plus 360 plus 360 plus 360. In other words, plus 360n for any integer value of n. And the same thing is true for 225. 225 degrees plus 360 degrees over and over and over and over again for any integer value of n. So your actual solution ends up being this. In other words, there are an infinite number of solutions, but they're very specific. It's those infinite number of solutions. All right, let's try another one. And maybe you might want to try it yourself before I do it. If you'd like to do that, go ahead and pause it. Here's what you should have done if you tried it on your own. So first of all, we're going to add 1 to both sides and then divide by 3. At this point, we'll take the square root. And so we'll have that the tangent of x equals plus or minus 1 over root 3. Rationalizing that, multiplying the top by root 3 and the bottom by root 3, we'll get plus or minus root 3 over 3. I guess I should put the plus or minus. Plus or minus. Okay, so let's say that you are not familiar with where the tangent of x is root 3 over 3. I know a lot of you guys are familiar, but it's not directly on the unit circle. So I'm going to go to Desmos and kind of cheat a little bit and see what I can do. So here is a tangent of x. It repeats every 180 degrees. It has a period of 180, as you can see. And I want to know, where is it going to equal root 3 over 3? So it's going to equal at 30 degrees, at 210 degrees, at 390 degrees, at negative 150 degrees, and so on. Every 180 degrees, starting at 30, adding 180 forever and ever and ever, or subtracting 180 forever and ever. So I can go ahead now and go here and say that my solution is going to be x equals 30 degrees plus 180 over and over and over and over and over and over again. I can leave it at that. If you want, you could write it in radians, and we should probably get used to doing that. So I could say it's pi over 6 plus pi n. So that would be your answer in radians. And I'm going to box that up. There it is. Okay, so those are the first 2 examples. Let's take a look now at some that are a little bit more difficult. And this guy right here. What am I doing wrong? Okay, good. Let's see. This one has a cotangent, and it has a cosine squared, and it has another cotangent. So it's kind of like, what in the world am I going to do with this? I will tell you, please resist the temptation of dividing both sides. It is tempting to do it, but don't. I'll show you why in a second. Let's go ahead, instead of doing that, let's get a 0 on one side. So let's go ahead and subtract 2 cotangent of t, 2 times the cotangent of x from both sides. So negative 2 times the cotangent of x plus the cotangent of x times the cosine squared of x equals 0. And what we can now do is we can factor out that cotangent. So take out the cotangent of x, and we're left with negative 2 plus the Oh, whoa, I really messed up there, didn't I? No, I didn't mess up. We're good, we're good, we're good, we're good. My bad. I thought I messed up for a second. So now I have that this times this equals 0. So I can split this in half, and I can say that either the cotangent of x equals 0 or negative 2 plus the cosine squared of x equals 0. So let's do this side first. So adding 2 to both sides, I get that. And taking the square root, I get that the cosine of x could equal plus or minus the square root of 2. Now the square root of 2 is about 1.4. Can the cosine of an angle equal 1.4? No, the cosine can never be more than 1. So this part here, you're not going to get any solution from that part. This is going to be a no solution piece. The cosine, which is the adjacent over the hypotenuse, can't be more than 1. Now the cotangent of 0, just as a reminder, you guys might remember that the cotangent is the cosine over the sine. So if I want this to be 0, I need to know where is the cosine going to be 0. And of course, the cosine is 0 at pi over 2. So I can say that x will equal pi over 2. The cotangent, like the tangent, repeats every 180 degrees. So we're going to do plus n pi. And there is your solution. In other words, my bad, sorry about that. In degrees, it'd be 90 degrees, 270, 540. So you start at 90 degrees and you keep adding 180 degrees. So, good enough for that. Now, why would you not divide both sides by cotangent of x? So let's go ahead and try that. You never want to divide both sides by a trigonometric ratio at all, ever. And here's why. If we divide by the cotangent of x and divide by the cotangent of x, that goes and that goes, and I get the cosine squared of x equals 2, which is this. And of course, I get no solution, and I'm done. But there is a solution. It's this one right over here. So what went wrong? Well, what went wrong is that we divided by 0. Look, the cotangent of x equaling 0 is what gave us our solution. So here, by dividing by 0, we ended up getting the completely wrong answer. So what went wrong? You inadvertently divided by 0. And you don't want to do that ever. So don't just divide by the sine of x or the cosine of x or tangent of x on both sides, because you don't know if you're dividing by 0 or not. So don't do it. Okay, let's go to the third screen. And this will be the last example for this particular video. And this is where we're going to be solving trigonometric equations of quadratic type. In other words, they're going to have a squared in it. So it's actually not going to be very hard to do. What we're going to basically do is we're going to pretend for a second that instead of having the sine of x, let's just say that let the sine of x equal a. So I can rewrite my equation as 2a squared minus a minus 1 equals 0. And all of a sudden, you're back to algebra 1 or algebra 2, and it's easy to solve this. So let's go ahead and solve it. We can solve it by factoring. So 2a times a, put a 1 there, a 1 there. I need a negative a, so those are my signs. So now what I know is that either this equals 0 or this equals 0. So I can go ahead and split this in half and say either that 2a plus 1 equals 0 or a minus 1 equals 0. Solving, I get a equals negative 1/2 or a equals 1. But a isn't really a. What's a? It's the sine of x. So now let's go ahead and put the sine of x back in here. So I want to know where is the sine of x negative 1/2 and where is the sine of x equal to 1. So on the unit circle, very simple. We know that the sine of x equals 1 at pi over 2 or 90 degrees. And it equals negative 1/2 at 7 pi over 6 and at 11 pi over 6. And you can get that straight from the unit circle. Nothing tricky about that. Now, notice what it says here. It says solve this equation over this interval. In other words, it wants only the solutions from 0 to 2 pi. And therefore, those are going to be my 3 solutions. I'm not going to have an infinite number of solutions because we're restricting the domain on this one. Let's go ahead and graph it. I'm encouraging you to graph it right there. Let's go ahead and try that because it's good for you to see it. So I'm going to take this equation here and I'm going to graph it in Desmos and watch what happens. So y equals 2 times the sine squared x minus the sine of x minus 1. Wow, that's a weird looking graph. And I only want to know the solutions between 0 degrees and 360 degrees, right about there. And I want to know where does it equal 0. All right. There, there, and there. So my equation was 2 times the sine squared of x minus the sine of x minus 1 equals 0. So I want to know when it equals 0. And it equals 0 at 90 degrees, which is pi over 2. At 210 degrees, which was 7 pi over 6. And at 330 degrees, which is 11 pi over 6. Of course, there are more solutions. They keep going. 450 degrees, blah, 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 blah. But the question wasn't asking for all of them. It was only saying between 0 and 2 pi, or between 0 and 360 degrees. Okay, let's finish it off with this one. This guy is problematic because it has both a sine squared and a cosine. If you had no clue, just graph it. Put this on one equation and put y equals 0 on the other and see where they cross, and you're done. You would get it right. However, you need to know more than that. So let's go ahead and use an identity to get them all either sine or all cosine. One identity you might remember is this, that the sine squared of x equals 1 minus the cosine squared of x. That's the Pythagorean identity. You should have that one memorized. So now we could write this as this, 2 times 1 minus the cosine squared of x plus 3 times the cosine of x minus 3 equals 0. At this point, I would really encourage you to pause the video and try it yourself. You should be able to solve that. Here's what you should have done. 2 minus 2 times the cosine squared of x plus 3 times the cosine of x minus 3 equals 0. Combining our like terms, which are only this guy and this guy, not too exciting, we'll get negative 2 times the cosine squared of x plus 3 times the cosine of x minus 1 equals 0. I don't like a leading coefficient that's negative, so I'm going to multiply everything by negative 1. And if you don't mind, I'm going to cheat to do that. I'm going to make this positive. I'm going to make this negative. I'm going to make this positive. Now I'm going to factor it. So I could use this, let the sine of x equal a. I could say let the cosine of x equal a. But this time what I'm going to do is I'm going to just go ahead and see if I can factor it like this. See if you guys can handle that. All right, I need to get a positive 1, so it's going to be a negative times a negative. Check, 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 check. Yep, it works. So now I can split this in half. So 2 times the cosine of x minus 1 equals 0, or the cosine of x minus 1 equals 0. In this case, I have the cosine of x equals 1/2. In this case, I have the cosine of x equals 1. And again, you can just go to your unit circle, and you can just spot them right there. The cosine of x is 1/2 at pi over 6. No, pi over 3, 60 degrees, my bad. And it is also 1/2 at 5 pi over 3. The cosine will equal 1 at exactly, well, it's kind of strange there. It's either at 0 or 2 pi. So I'm going to call it 0, I guess. However, notice that on this one, there isn't this restriction. It doesn't say only for that, so I want all of them. So it's going to be at pi over 3, or 60 degrees, plus 360, plus 360, plus 2 pi, plus 2 pi, plus 2 pi. So it's going to be plus 2 pi n, or 2n pi. Same here, plus 360 degrees. Same here, plus 360 degrees, or 2 pi n. So there are an infinite number of solutions. There are 3 solutions between 0 and 2 pi. And then there are more solutions if you keep on going because it's periodic. Okay, I think in your book, they will often have 2n pi instead of 2 pi n, but that's the same thing. All right, so you can now try the first 8 in your assignment, the 8 that are listed right there. If you have any questions, please let me know. I'd be glad to help you. All right, see you in video 2 in just a bit.